Hi guys, it is math time. We are on lesson 3, use division to solve multiplicative comparison problems. So hopefully you've got your packet for lesson 3 that was in your materials that went home last week. It should say page 61 at the bottom of it. It's stapled together in a little packet for the lesson, and we'll go ahead and get started on page 61. And let me just flip my camera around and put it down. Alright, and you can see here we are. Hopefully your packet looks just like this one. That should tell you you're in the right place. So today I want you to take a look at the I can statement. I can, by the end of today's lesson, you should be able to solve a multiplicative comparison problem by using division with drawings and equations. So the things I want you to focus on are multiplicative comparison, what we were working on earlier this week. I want you to focus on the fact that we're going to be using division, okay, to write both drawings and equations. Okay, so the first part of the lesson goes right into the step it out today. So step it out. Olivia is in the photography club. She takes 15 photos at a garden. That is 3 times as many photos as she takes at school. How many photos does Olivia take at school? Okay, I'm going to give you a moment to read that one more time for yourself. Alright, it says Olivia is in the photography club. She takes 15 photos at a garden. That is 3 times as many photos as she takes at school. How many photos does Olivia take at school? So I always start out by asking myself, did she take more photos at school or at the garden? Well, this is now, I'm going to start to do a little surgery on my problem here. It says she takes 15 photos at a garden. That number, 15, is 3 times as many photos as she takes at school. So 15 is more than 15 at the garden is 3 times as many as she takes at school. So school is the unknown number. Okay, so on this line we're going to write school because we don't know how many photos she takes at school. What we do know is that in the garden it said that she took 15. So how can I use division to help me? Well, if I've got 3 boxes here and it says 3 times as many photos as at school, I want to take the total amount that was at the garden, 15, and split it into 3 equal groups. So basically I'm thinking to myself, how can I split 15 into 3 equal groups? Okay, hopefully you're able to think 5, 10, 15. So 3 5s is 15. So what would that look like as an equation? Okay, so we use the bar model here. Down here it says write an equation to model the problem, use n for the unknown. So the problem is 3 times as many as n is 15. 3 times as many as n is 15. So 3 times as many as n is 15. Looks like that. So we C says now we're going to use the inverse operation. Okay, you may have heard that term before. Inverse operation just means the opposite of what's here. So they gave us a multiplication equation to begin with. So the inverse, or the opposite of multiplication, is division. So 15 divided by what we know, 3, is going to give us our n. Okay, 5 equals n. Olivia takes 5 photos at school. Okay, so since remember the I can statement at the beginning of the lesson said that we're going to be able to do it with drawings and equations. This is our drawing, the bar model. This is our equation down here. The equation is division. 15 divided by 3 equals n. 5 equals n. So therefore Olivia takes 5 photos at school. Okay. Don't ignore this little graphic over here. Okay, inverse operations such as multiplication and division undo each other. So 3 times 2 is 6 is the inverse or the opposite of 6 divided by 3 equals 2. I always think of it as tying your shoes and untying your shoes. Tie your shoes, and then the inverse of that is untying your shoes. So it just kind of undoes, when they use that phrase, undo each other. You can think of that as untying your shoes. It's the opposite. It's the inverse. Okay? The next, step it out on the next page, 62. Okay, I'll do the first read. This year, 28 students are in the chess club. Last year, 7 students were in the club. How many times as many students are in the chess club this year than last year? Write a multiplication sentence. Write a multiplication equation to model the problem. Sorry, I'm just looking at something here that I'm trying not to look at. There we go. That's better. Sorry, guys. All right. So now take a moment to read this, step it out to yourself, number 2. Okay, a third read now for me. Now I'm going to use this opportunity to slice up my question and underline and circle important information. This year, 28 students are in the chess club. Last year, okay, so this year versus last year, 7 students were in the club. How many times as many students are in the chess club this year than last year? How many times as many is what we're trying to figure out, right? And we want to use division to help us. So first we need to think about what's given to us. Okay? What's given to us is that the unknown value, we're trying to figure out how many times as many students are in the chess club this year. Well, we take our unknown value, and we know that last year 7 students were in the club. So something times as many times 7 will give us the number of students in the chess club this year, 28, right? Okay, so now if we're thinking about that, then we would do the inverse operation, or the division equation now. We take the number of students from this year, divide it by the number of students from last year, and that will give us our unknown value. Okay, what's our unknown value? Well, it's the answer to 28 divided by 7, which is 4. Okay, so this year we would say, this year, 4 times as many students are in the chess club. Okay, so think about that. In 2019, if there was 7 students, and then I said there was 4 times as many this year, that would be 7 times 4, which is 28. Okay, now you can't really turn and talk unless you've got somebody sitting next to you, but why can you use division to solve a multiplicative comparison problem, but not an additive comparison problem? That's a good question. Okay, pause your video and think about that for a moment. Why can you use division to solve a multiplicative comparison problem, but not an additive comparison problem? Okay, hopefully you were thinking that division is the inverse operation of multiplication. So division undoes multiplication, but it is not the inverse of addition. Okay, the inverse of addition would be subtraction, right? So that would be one reason why we can't use division to for a multiplicative comparison problem. Okay. Down at the bottom of the page, we see check understanding. Okay, let's check our understanding now. The directions say write multiplication and division equations to model and solve the problem. Use n for the unknown. Okay, so we're still going to have our pencils ready to underline any important information from the problem. Leslie collects 24 aluminum cans and 8 glass bottles for the recycling club. How many times as many cans as bottles does Leslie collect? Okay, how many times as many? So we're going to use the n for the unknown value. So it says how many times as many cans. So when it says how many times as many, I'm going to start out with my unknown value. How many times? I don't know yet. How many times as many as cans, which it says here, how many times as many cans as bottles does Leslie collect? Well, if I take my number of glass bottles and I know that there are 24 cans, in order for me to figure out how many times as many bottles as cans as she has, is I want to set up my equation so it looks like that. Then I will use the inverse, or the opposite. I'm going to basically turn this equation around. Take 24, divide it by 8, and that will tell me what my how to get my answer for n. Okay, so I'll use what I know about fact families. 24 divided by 8 is 3. So therefore n equals 3. So Leslie collects 3 times as many cans as bottles. Okay. Number 2, the students in the cooking club bake 12 blueberry muffins. They bake twice as many blueberry muffins, as corn muffins. How many corn muffins do the students make? Okay, so twice as many means 2 times as many, right? So 2 times as many as, I don't know the number of corn muffins, do I? How many corn muffins do the students bake? So 2 times n equals 12, which is the number of blueberry muffins. They bake twice as many blueberry muffins as corn muffins. So in other words, it's got to be 2 times something to make it the amount of 12. Now I'll use my inverse operation. 12 divided by 2 equals n, and n equals 6. Okay? You may have been able to look at that problem and say, well, what number is 12 twice as many as? Well, I know that 6 times 2 is 12. Okay, that would have been a little shortcut for you. All right, so that way we can say the students bake 6 corn muffins in the cooking club. All right? I know it might be confusing, guys. The wording is like you got to be very precise and technical and exact with the way that these questions are worded. Otherwise, you might wind up doing the wrong operation. Believe me, I get it. Okay? That's why we're practicing, and the more that you see these types of problems, the more familiar and comfortable you'll be with them. Okay? Now, this is the time that we would normally try this on your own. So page 63 is the on your own section. Okay? I'd like you to pause the video and try it on your own. And when you check back with me, you can compare your answers with how you did. So go ahead and take a few minutes and pause your video, practice the on your own. Okay? If you would like to hear me read the questions, you can listen to the question, then pause the video, and practice solving on your own. Okay? So take a minute, go ahead and pause your video and try these on your own. And we're back. Okay. Number 3 says, the library club receives 56 fiction books and 8 nonfiction books. How many times as many fiction books as nonfiction books does the club receive? All right. I really think that these bar models are the way to go. I like to see the visual here. So I know that there are 56 fiction books, and I know that there are 8 nonfiction books. So the bar model is showing me 8 as one nonfiction, but I know that each box represents 8, and it says I've got 56. So basically I would skip count until I get to 56, or you could do it a better way. Okay? You could say the club, well, 1, 2, 3, 4, 5, 6, 7 eighths equals 56. So I could say the club receives 7 times as many fiction books as nonfiction. Okay, this visual model here shows me I have 1 times as many, right, to begin with. If I move over to 8, that would be 2 times as many, 3 times as many, 4 times as many, 5 times as many, 6 times as many, 7 times as many. So 8 times 7 is 56, and my question says there was 56 fiction books. Okay, so building a good understanding of your multiplication facts. That's why it's so crucial, guys, to make sure you're doing reflex math each day. All right, number 4. Bob fills a basket with carnations and roses. He uses 18 roses and twice as many roses as carnations. How many carnations does Bob use? Okay, this is why when it becomes very important to understand what each number in the problem stands for. Okay? So imagine this basket of flowers here. He fills the basket with carnations and roses. So there's some amount of flowers in there that we don't know. Okay? He uses 18 roses and twice as many roses as carnations. So right now ask yourself, do you think he uses more roses or carnations? He uses 18 roses and twice as many roses as carnations. Okay? You could say he uses 18 roses, which is twice as many roses as carnations. So, we know that it's 2 times something because it says twice as many. So 2 times something will give me the number of roses, which is 18. Okay? So now you're probably thinking to yourself, oh, 18 divided by 2 is n. Okay? So what does n equal? It equals 18 divided by 9. 18 divided by 2 is 9. So to make this basket, Bob uses 18 roses and 9 carnations. And I know you guys, one of you is going to count the flowers in that basket to see if that's true or not. I don't know that it is. Okay. Number 5. A sweater costs $40. That is 5 times as much as a shirt. What is the price of the shirt? Write multiplication and division equations to model and solve the problem. You use S for the unknown. Okay? So a sweater costs $40. We know that. So that's 5 times as much as a shirt. So 5 times, and they want us to use S for shirt. So 5 times the amount of the shirt equals $40. Okay? So now we can use the inverse of that equation and do 40 divided by 5 equals S, which is the cost of the shirt. So how much does the shirt cost? It costs 8. So I would say the price of the shirt is $8. Okay? Alright, now, number 6 says open-ended. Write a multiplicative comparison word problem that can be modeled and solved with the equations 7 times m equals 21, and 21 divided by 7 equals m. Alright? So you could have lots of different examples for this. Okay? I like to stick with what I know here, so I might say something along the lines of, let's just say, Mr. Callan ate 21 chicken wings, which is 7 times as many as Trevor. Okay, so what am I trying to figure out? I'm trying to figure out how many chicken wings did Trevor eat? Trevor, I don't even know if you like chicken wings, but I do. Okay, so if I ate 21 chicken wings, and that's 7 times as many as Trevor, I would say 7 times as many as Trevor equals 21. Therefore, 21 divided by 7 equals m. So therefore, m equals 21 divided by 7 is 3. Okay? Trevor only ate 3 chicken wings, and I ate 21. Sounds about right. Okay. All right, so yours does not have to look just like mine. You might have some variation. Okay, everybody's going to do something different, but hopefully you said something about how many 21 being 7 times as many as another number, and then your equation would look similar to this. Okay. Okay, I'm over on page 64 now. We're continuing with the on your own section. So if you're over there with me, this should be something that you're trying on your own first and then coming back to watch afterwards. Okay? If you need to pause the video, now is a good time. If you want to hear me read the problem, then pause the video, you could do that as well. In the martial arts club, students spend 20 minutes working on blocking. That is 4 times as long as they spend meditating. How many minutes do the students spend meditating? Okay, so we're trying to find out how much time they spend meditating. Okay, we don't know that. We do know that the students spend 20 minutes blocking. 20 minutes is the total amount down here. And if you notice, the amount is split into 4 equal boxes. So it's like I'm doing 4 times the amount of time meditating, which will give me the total amount of time blocking. Okay? So now, in order to solve, I want to take my time blocking, divide it up by 4, which will give me the amount of time meditating. Okay? So how could I split this 20? What amount can I split 20 or divide 20 by 4 to get an amount of time in there for blocking? Well, 20 divided by 4, 5, 10, 15, 20. Okay? So over here in my boxes, m equals 5. So that would mean that there is 5 minutes meditating. Okay? Okay, number 8. Students in the engineering club build 2 train tracks. Track A is 24 feet long. That is 3 times as long as the length of track B. What is the length of track B? Okay, so we've got track A, which is 24 feet long, which is 3 times the length of track B. You could draw a bar model like you saw up above. You could write an equation. Okay, so let's try an equation since we just did a bar model up there. Okay, it says 3 times as long as the length of track B is track A. So 3 times the length of track A will give you the length of track B. Okay? 3 times as long as the length of track B. So 3 times something will give me 24. And 24 divided by 3 will give me my unknown value. So 24 divided by 3 is 8. So therefore I know n equals 8. So track B is 8. What do we have? Feet long. Okay. If you wanted to do a bar model, okay, we would say that the track A is 24 feet. Track B is 3 times, track A is 3 times the length of track B, so we'd split that into 3 equal groups. And these two things, so we've got 24 divided by 3 basically, So each length would be 8. So our model would look like that. Okay? All right, and our last question for today, folks. Kevin walks 6 laps and jogs 2 laps. Kevin writes this equation to find how many times as many laps he walks as jogs. Is Kevin correct? Okay, let's look at his work here. It says 6 times 2 is n, 12 equals n. I walked 12 times as many laps as I jogged. Does that sound right to you guys? Okay. Again, it says he walks 6 laps and jogs 2 laps. Did he walk 12 times as many laps as he jogged? No. He took the numbers from the problem and multiplied them. The only issue with that is this is a comparative problem. So it's not just asking you to multiply those 2 numbers. Okay? If you wanted to write an equation that showed that comparison, he might start out by saying something like the number of how many times as many laps he walks as jogs might look something like this. Some amount that we don't know times 2 is equal to 6. Okay? Then you can use the inverse operation, 6 divided by 2, to equal n, and n equals 3 times as many. Okay? I know it's not crystal clear, guys. I know it's confusing. I know the wording is tricky, but the more practice you get with it, the easier it will become. This is a big 4th grade standard, these comparative multiplicative problems. So that's why we stopped to spend the time on it and learn the lesson so everybody can be prepared for moving on. Ooh, I'm very zoomed in there. How you doing? Back it up a little bit. Okay. All right, so I stated in the directions you can split this lesson into 2 days if you want to. So take the next day to spend the time going over it, practicing it, reviewing it, and then the homework, more practice paper will be assigned for tomorrow. So good luck, do your best, be patient, don't get frustrated, and I will see you guys the next time. Have a good one.